Hello dear students, today we are going to discuss something about the periodic properties. About the periodic table you have learned in grade 9. So today we are going to discuss the periodic properties. Now, what is the meaning of the periodic properties? Periodic properties means the properties which are going to repeat. Repeat means like the properties are going to change and they are going to repeat once again. So that is going to happen when we are going to see the properties in the periodic table. When we move across the period, that is from left to right of the periodic table, the properties are going to change. And when again the another column will be there, that is another period, the same properties are going to repeat in the same manner. So that is known as periodic properties. So where there are different kind of the periodic properties, so we are going to discuss it one by one. So the first periodic property we are discussing is atomic size. Now when we say atomic size means that the distance between the nucleus, suppose this is an atom, okay, and in the center of an atom the nucleus is present. So the distance between the nucleus and the outermost shell electron is known as atomic size. Outermost shell is also known as valence shell. So basically the distance between the nucleus and the outermost shell is known as atomic size. Okay, now we are going to see that how this atomic size is going to vary down the group and across the period. Now first we are going to see that how the atomic size is going to vary down the group. Now as you can see, the size of an atom, you can see here, it's quite increasing when we are moving down the group. So it means the atomic size is going to increase down the group. Now why it is going to happen? Atomic size is going to increase down the group because when we move down the group, the number of shell are going to increase one by one. If you have observed the periodic table, suppose we see the first group. In first group also you can see from lithium, sodium, potassium. You will find that when we move down the group, the number of shells are increasing by 1. It means when the number of shells are going to increase, the distance between the nucleus and the outermost shell is also going to increase. So when the distance between the nucleus and outermost shell is going to increase, it means the atomic size is going to increase. Okay. So when we move down the group from top to the bottom of our group, like suppose I'm giving you one example, lithium, sodium, potassium. This is about first group. When we are moving down the group, the atomic size is going to increase. Okay. So it is going to increase because the number of shell is going to increase by 1. Now we move to the another part, how the atomic size is going to vary across the period. If you can see the size of an atom here, it's going to decrease when we move left to right of the periodic table. Okay, it means across the period when you are moving, then the atomic size is going to decrease. Now why atomic size is going to decrease here? Here the number of shell is going to be same. Number of shell for an atom is going to be same, but the number of electron as well as proton are increasing. So when the number of electron and protons are increasing, okay, and the number of shell is remaining same, then it will increase the nuclear force. Okay, it will increase the nuclear force. So when it will increase the nuclear force, the force of attraction between the nucleus and the electron is going to increase. And you all know that protons are much heavier as compared to the electron. So electrons are going to be pulled more toward the nucleus of an atom. So when electrons are going to be pulled more toward the nucleus of an atom, it means the size of an atom is going to be decreased. Okay, so when we move left to right, the size of an atom is definitely going to be decreased. Then the next property is there, which is known as nuclear charge. Now nuclear charge, as you can see, this is the atom I have represented. In the center there is a nucleus. In nucleus you all know there is proton and neutron present, and in the outermost shell the electrons are present. So basically protons are positively charged and electrons are negatively charged. So the attractive force between the nucleus and the valence shell electrons is known as nuclear charge. Okay, because the opposite charges attract each other. Okay, now we see that how the nuclear charge is going to vary down the group and across the period. Now down the group, the nuclear charge is going to decrease. Why? Because the distance between the nucleus and valence shell increases. Okay, when the distance between the nucleus and the valence shell increases, the nuclear charge is going to decrease. It's just like that if we are having a magnet and if we are taking the magnetic substance, like suppose a piece of iron, away from the magnet, then the force between the magnet and the iron piece will be decreased. Same is going to happen here. As you have already seen, when we are moving down the group, the number of shells are increasing one by one. So when the distance between the nucleus and the valence shell is going to increase, the nuclear force will become weak. Okay. Now, the second thing, across the period, opposite to that will happen, as the nuclear force is going to increase. Why? Because the number of shell is remaining same here. The number of shell remains same here. Okay. But the protons and the electron number is continuously increasing. Okay. Because when we move across the period, the number of electron in the outermost shell start increasing one by one. Okay. So when the proton and electrons are increasing, it means the attractive force between the nucleus and the outermost shell will be increased. And when the attractive force will be increased, electron will be pulled more toward the nucleus. It means the nuclear force is going to increase. So across the period, the nuclear force is going to increase. Okay. Now next is ionization potential. Now what is the meaning of this ionization potential? Ionization potential means the amount of energy required to remove the electron from isolated gaseous atom. Now see, if suppose an electron is present in the outermost shell and it is required to be removed from the outermost shell, that is, it tried to come out of the nuclear force, then it requires some energy to come out of that force. Okay. So when that electron will get that much amount of energy so that it can overcome from nuclear force, so it will be removed from the outermost shell. So the energy which is required at that time is known as ionization potential. Now for this, the atom is required to be in the isolated gaseous form. Okay, then only the electron is going to be removed from the outermost shell. So the amount of energy which is required to remove the electron from the isolated gaseous atom is known as ionization potential. Now, how the ionization potential is going to vary down the group. Now, all these things are related to the previous properties. Now, as we know, down the group, the nuclear force is becoming weak. We know that down the group, the nuclear force is getting weak. When the nuclear force is getting weak down the group, it means the energy which is required to remove is also less. It means the ionization potential or ionization energy, that is the same thing, is going to be decreased. Less amount of energy is required to come out of the atom, because the nuclear force is weak. So less amount of energy is required by an electron to come out of an atom. So hence the ionization potential is also going to decrease down the group. Then the next property is there, that is across the period. How this how this ionization potential is going to vary across the period. As we know that the nuclear force, it is directly related to the nuclear force, is going to increase when we move left to right of the periodic table. Okay. So it means when the nuclear force is going to increase, then the amount of energy which is required to remove the electron from the isolated gas atom will also going to increase, because more energy is required by an electron who came out of the nuclear force. Because more is the nuclear force means more the amount of energy required. Hence, across the period, the ionization potential is going to be more. It means, suppose if we compare the sodium and magnesium, then sodium will be having less ionization potential, while magnesium will be having more ionization potential, okay, across the period. But when same sodium is compared with the potassium, as potassium is present in the same group as is sodium, so in such case, the sodium will be having the more ionization potential and potassium will be having the less ionization potential. So that is how the ionization potential is going to vary across the period and down the road. Now, this for this video, now that's all. For the next video, we are going to discuss further about some of more periodic properties, and we are going to discuss that about the periodic properties across the period as well as down. Thank you, students. Goodbye.